Welcome back. We're now doing a new video. It's still part of our casual game mechanics series. This one's going to be about the agility and swerving mechanic and timing, but this time we're going to be doing it in C sharp. So I'm just going to be opening up my scenes. So I'm going to make sure that I essentially just created a very wrong scene, a simple scene where all these little platforms are equally spaced across from one another. I'm just going to delete every other one for now. We're not at the point where we're going to have multiple platforms, good platforms and bad platforms. So there we go. So I just created this. We're going to be doing some proc gen or procedurally generated levels so that we at a later stage, so we don't have to worry about building an entire level out of this. We're going to generate that in code. So now what we're going to do now is this is my script that I created from our simple follow script tutorial. I just applied it to the object and I just told it to follow the player in the Z. Remember to assign the player tag to the player for that to work. Let me remove this. Apparently there was a script on here. I just moved the character above the ground just a fraction so that I can show you what's going to happen from here onwards. So in a lot of cases, you could generate the level and move the level towards the player. In this case, I actually want the player to move forward. Just for this, there's so many ways to do the same thing. So in this case, I just decided the character is going to move forward instead of the level moving towards the player. Okay, let's just see what we've got on the object. We have a rigid body. We're going to turn on use gravity and make sure we lock the rotation. And we're going to start by adding a script to this character. I'm going to go to my scripts folder. I'm going to create a new script. Just call this spell it properly. Agility, dexterity, timing. Controller. You don't have to call it this long. I'm just doing this so just for filing purposes. Let it compile, and we're going to wait for that to happen, and then I'm going to assign this directly to. Let's try that again. Directly to the player. There we go. Okay, so what we're going to do is as follows. We are going to need a plane, a surface to which to raycast, because this game is based on a mobile game called Tiles Hop, and you move your finger around and side to side, and the character moves side to side. So that's all the movement we want to get. So when I hold down the left mouse button and I move side to side, I want the ball to kind of follow my cursor. But I need to kind of have a surface to raycast to. And I was going to use planes, generate a plane in code, but I just want to keep this as similar to Bolt as possible. So we're going to do it the same way we did in the Bolt. So on the camera itself, I'm going to right click. I'm going to create a new plane. You'll see that the plane is there. I'm just going to counter the rotation of the camera by doing -20. And then I'm just going to reposition the camera somewhere where the character would be, the starting point of the character. Somewhere over here is good enough. And I'm just going to make it a little bit bigger so that there's no chance you won't have a raycast from side to side of the screen. Okay, and for the raycast to work, I always work with layers when it comes to raycasting. So I'm going to go and I added a new layer called hit area. And then I'm going to assign it to this object. And I'm going to turn the mesh render off because I don't want it to be visible in the game. I just want it to be visible to the raycast. So the next issue is if I were to move the ball across now, you'll see what I mean and why we're doing what we're going to do. So if I move it across here and I push play, it's going to land on the plane. So I don't want that to be the case. So we need to select the plane. Because it's using a mesh collider, we need to make it convex first and then turn it to is trigger. That way it will no longer, the character will just fall through the plane. It won't use it as an actual surface that it can collide with. There we go. Okay, so now that all of that kind of groundwork is done, we are pretty much ready to open up the script. Again, a quick reminder, if you open up your script and your IntelliSense doesn't work, just go to Edit, Preferences, go to External Tools, make sure Visual Studio is selected, or Visual Studio Code, depending on which one you use. Make sure Local Packages is ticked on, and after that, just click the Regenerate Project Files. And then once you're done with that, make sure that both Code or Studio is closed, and go to the script, and open up the script, and then hopefully by the power of the gods it should work. Okay, now we're going to do a few things here. I'm going to first start off by removing these comments. I don't need them for me. right at the top here, I'm going to start by getting the ball to bounce. So the logic behind what I'm doing here is I'm going to, every time the ball hits the surface at the ground, it bounces like a real ball would. So I don't want the ball to be moving constantly forward. I want it to move forward every time it bounces on something. So let's create a serialized field. This one is going to be a float, and we're going to call this one forward hop. Let's call it that. Set a default value of something like 5. And we're going to do the same thing again. Let me just duplicate that line of code with Control-Shift-D and just change forward hop to up hop. I know, makes no sense, but I'm kind of rolling with it now. So a forward hop and up hop, and we're not going to be doing it in the start or the update. We're going to be doing it on collision enter. So when it collides, we're going to do something. First thing, oh wait, one more thing. We need a rigid body reference. So we're going to go private, rigid body, RB. And we're just going to assign the rigid body before we forget. So RB is equal to get component rigid body, like that. Remember, this only works if the script and the rigid body are on the same game object. If they're not, this is not going to work. So just be aware of that. So whenever I do kind of any weird physics stuff, I always kind of, before I start adding velocity or force, I always kind of like to zero out my velocity, my current velocity. Same thing what I do with characters. When I do a character controller based on physics, I always kind of zero out the velocity before a jump or on a land, so that there's no lingering force or velocity that could affect the movement afterwards, because I like to have reliable results. So we're going to zero out any force here. We're going to go rb.add force. And we're going to add force in both directions. So we're going to start with transform.up, and we're going to multiply that by our up hop value, and then we're going to add that to our transform.forward and multiply that by our forward hop value. And all we need to do is add a comma and just choose what kind of force mode we want to use. I want to use impulse in this case. I just want to get apologies. I just want to have almost kind of like a poppy, an instantaneous force added. So if we go back to Unity, we can test this out. Sorry about Bolt popping up every time. I don't know what it is, and I'm not quite sure how to fix it, but every time it recompiles the script, the welcome screen of Bolt pops up. So there's our variables, our forward hop and our up hop. And when the object hits the ground, it should hop forward. There we go. So it's a little bit short, so I'm going to kind of go for, I know the value is 5.7 and 6 for me because of the distance these objects are away from each other, but I am aware of that's how far. There we go. Okay, so now it's hopping forward. So now all we need to do is go in and say, when I hold down the left mouse button and move side to side, I just want the left mouse button to be down so that if you're not just moving the cursor around just before you start the game, it doesn't do anything weird. So you need to initiate the move by holding down the left mouse button and then move the character around. So let's get that going. But for this next situation, I'm just going to turn off gravity just to show you. But remember, we need to turn that back on. Okay, so now that we have all of that, all we need to do now is actually physically move the object here. So we will require two things. We're going to need a private ray. We need a reference to the ray because we're going to generate a ray from a position of our mouse, where our mouse is. And we're just going to call that ray. And another one, because remember we're using raycast, so I want to create a layer mask reference. Let's call this raycast layer. So the layer that we're going to raycast to, I'm just going to move that up so that all the serialized fields are together. I think for now that should be good. So in the update, we are going to go and say the following. We're going to say ray is equal to, and what is it equal to? It's, wait, we don't have a reference to the camera. That too, cheapest. We keep adding stuff. So let's make a reference to the camera. I'm just going to call this player cam. And at the start, we're going to tell it that the player camera is going to be, we're going to find object by type, and we're going to look for, I think we called it simple camera follow. There we go. Okay, and remember, it's not looking for game object. We're looking for the actual camera component. So we're going to go, get component camera, and there we go. Okay, so over here we were doing that. Originally we're going to go player cam dot, and we're going to go screen to ray, and we're going to look for input dot get mouse position. Position. Let's try that again. Oh, sorry, it's not get mouse position, just mouse position. So now that we have the mouse position and it's updating the array, we can then do an if statement to check to see what's happening. So over here, we're going to say we want to first say input dot get mouse button 0, which is our left mouse button. Now get mouse button means get mouse button down fires off once when you click the button, and then get mouse button up is when you release the button, fires off once. But get mouse button is almost like an update. So as long as the mouse button is down, it's going to do something while that button is happening. So we're going to check to see if the mouse button is down, and we're going to do the raycast. So we're going to go physics.raycast. We're going to start from the ray position, and we are going to need a distance and an out hit. So I'm going to just type in out. Let's call it hit. We don't have it yet. We're going to create it, and I'm just going to go about 100 meters into the world, 100 units. And then the last one is our raycast layer. Okay, so the out hit we don't have, so we're going to just do it above here. So we're going to go raycast hit is equal to that, or that's the name of the variable. So that sorts out all of our issues. So all we're saying is if the left mouse button is down and this comes back as true, which means we do hit a raycast layer, we are going to need it to do a few things here, starting with creating another new variable. This one's going to be a vector3. Let's just call this ray to world position. Ray to world position. And what is ray to world position going to be equal to? It's going to be equal to the hit dot point. Do it again. Why is it? There we go. So that's the position we're getting it from the raycast where it hits the world. And all I care about is just the X position, because that's the direction the mouse is moving. So we're going to go and say ray to world position is equal to new vector3. Actually, we can remove this line above here. It's overkill. Let's cut that out. Let's remove this. I think it's too much. Okay, so now we want the hit position dot x, and then the rest is just from the object itself. We're going to say position dot y, comma transform dot position dot z. Okay, so let's test that out. So all we're doing here is we're saying this is based on the hit point x, and then the rest is just straight from this from the player itself. Remember, we need to actually assign it. So we're going to go transform.position is equal to ray to world position. There we go. And now we can test it. So we can go about seeing what's happening and see if it does the job. So again, I've turned off gravity. So all we're going to be looking for is to see if nothing should happen. Hold down the left mouse button. Okay. Problem 1, I forgot to set the layer that I'm raycasting to. Now we can try that again. There we go. So that works. So biggest issue, next step we have to figure out is how do we stop the character from leaving the screen? So we got to clamp that value. So that's what we need to do next. And then we're pretty much done with this entire input. So how do we go about doing that? We are going to create, again, 2 more new variables. So private, and this one's going to be a vector2. We're going to call this screen. Let's call it screen bounds. There we go. And the next one is, actually, this can be a float. It does not need to be a vector2, because we only care about the screen bounds X position. There we go. Okay, and then the next one's going to be a private float again, and this one's going to be player X size. What is the player's X size? Well, let's put the X at the end. It just makes more sense for me there. Player size X. And then at the start, we're going to go and say, okay, screen bounds.x is equal to, and we're going to go player cam.screen to world position. And what are we looking for? We are going to be making a new vector3. And again, we only care about the X position. So, but we're building this entire vector3. So we're going to need screen.width, because that's the X position, comma screen dot height. And then the last one, because whenever if you've ever worked with a screen to world point, you're going to realize you're going to get some weird issues if you don't actually put in, if you just don't put, if you don't put in the value here. So we're going to just say player cam dot transform dot position dot z. And all we care about, remember we have an area, so we're going to go dot x. Because all I care about is the x position out of this vector 3. Then all we need to do now is over here, we're going to say player size x is equal to, and what is it equal to? We need to get the mesh renderer from this object. So type in get component dot mesh renderer dot bound dot size dot x. Now I'm going to leave this as it is. It's a little bit broken, but I want you to see it so that when we come back and fix it, that's when the aha moment happens. So bound size x, because we only want the x position. So now we're going to do that, and we're going to feed it directly into here. So we're going to grab this here. We're going to create a mathf.clamp, because remember we want to clamp the value, and we're going to take the current value x, and we're going to clamp it between our screen x position. And I'm going to do one more thing just so that you can see what happens. And I'm going to try something really quick here. I'm going to go screen x position using the negative value. Let's just see what happens here. Okay, so we're clamping it between the positive and the negative value, and I'll talk you through this. So whenever this is the minimum value this side, and that's the maximum value that side. So the reason that this is a positive value is I'm saying stay on the inside of this frame, and the reason I'm putting a negative value is I'm saying stay on the inside of that value. That's at least the way I understand that logic and that code. Okay, let's see what happens now. Okay, nothing should happen. Left click. Notice how it gets to the end here and it's working, but it doesn't get past the screen. But notice how it's kind of halfway through the ball, halfway through the object, and that is where our player scale value comes in here. So we're going to say over here, we're going to add the player scale value. And again, over here, we're going to subtract the player scale value. Because remember, we need to add the value for the ball to be inside on the left, and we need to subtract it for the ball to be there on the inside on the right. So that is what we're doing here. So again, let's go try that out. Let's let it recompile. At least I guess the window popping up tells me when the script is recompiled. There we go. It's working, but notice how it's like almost half of the character's distance away from the edges. And this is where I spoke about the issue that we have. We don't actually need the entire size of the bounding volume. We only need half of this size. So we're going to take that, we're going to divide that by 2. We're going to go back in here, and we will now have a completely functioning controller. Once this is working, we can test a playthrough to see if we get it. There we go. It stays within. Keeping in mind, remember, this camera has got perspective, so you can you might want to play with the field of view, but this ball will never leave the volume. Like you'll see the cursor's leaving the game view, but the ball's no longer leaving the game view. Okay, so let's set everything up for it to work as advertised. Use gravity, and let's go through and play it through. And then that's pretty much it for this video. There we go. Boom, 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 boom. Done. Oh, okay, one more thing. Let's do a little bit of a lerp or interpolate of the position move. I feel that it needs it. We're going to create a new variable here, private float. We're going to call this new lerp position. Let's call it something like that, new lerp position. We are going to set the position of this new lerp position to be part of the like over here, we could just setting it straight up to this position here. Actually, no, we don't need it. We've got that is. We don't need this variable. We're just going to actually just select this, cut this. We're going to go mathf.lerp. What are we lerping? From the current transform.position. And we're going to go from that to that position there. And then we just need a time value. Like how long is it going to take to go from position A to position B? Just so that we get a nice soft transition there, we do need a variable. So over here, I'm just going to create a serialized field. It's going to be a float, and let's call this lerp speed. Apologies for my phone. That was crazy. There we go. We're going to copy the lerp speed and paste in here. And again, I always multiply it by time.delta time. It's just a safety mechanism. I just need to be able to do that. Oh wait, we need a vector3.lerp. What am I doing? There we go. Sorry, mathf.lerp does floats. Vector3.lerp, so move from the current position to the new position over this amount of time. So let's go and see what that looks like. 5 is relatively slow, so it should get, you should be able to see as the cursor is moving, the ball is going to try to keep up. There we go. Do you see how it's kind of got a little bit of like a delay? So there we go. So if just think of lerps as speedometers. So if the car or if you want it to go faster, then the value needs to be greater. So it travels faster to the new location. So 15 there we go. 15 almost gives me an instantaneous feedback, but it still kind of makes a really nice kind of soft transition. So I'm going to leave it at 15. I hope this has helped. Please, until we see each other next time, be safe, and I'm out. See you guys. Cheers.